It's a fire bridge to Asgard, forged by the gods. What? I thought it was a battle between St. Michael and the devil. Well, I thought it was the spirit of my ancestors dancing in the sky.
No, no, no. This is the Aurora Borealis.
The Northern Lights.
It has been appreciated for thousands of years, but only first studied in 1619 by Galileo Galilei. It all starts in the sun, a 4.7 billion year old ball of gas. Every now and then, the sun creates a solar storm.
What do you mean, a solar storm?
The sun produces energy by fusing together atoms in its core under immense pressures and temperature. Hydrogen nuclei,
protons,
collide, releasing energy to form a helium nuclei.
This is known as nuclear fusion.
Due to high pressures in the core of the sun, atoms are forced to split into their constituent parts, protons and electrons. This charged gas created is known as plasma.
The fourth state of matter.
The heat produced from nuclear fusion causes the plasma to rise, cool, and fall back to the core. This creates a convection current. The movement of charged particles,
the plasma,
in these convection cells induces a magnetic field. These magnetic field lines are under such immense pressures that they are often forced to meet. This leads to the magnetic field being forced out of the sun, ejecting plasma with it. This is known as a coronal mass ejection.
A solar flare.
Because this solar storm is travelling so fast, it can escape the sun's gravitational field.
Oh, right.
Solar storms can travel through our solar system at 8 million miles per hour. These solar storms are extremely dangerous. If they hit the Earth's surface, they can lead to our extinction.
So why aren't we dead?
Luckily for us, Earth has its own defence system. Just like the sun, Earth produces a magnetic field. Surrounding Earth's solid iron core is a layer of flowing liquid iron. Similar to the sun, the movement of this iron creates a magnetic field which encompasses the Earth. This protective barrier is called the Earth's magnetosphere, and it extends thousands of kilometers into space. Since a solar storm is made up of charged particles, it too has a magnetic field. When the charged particles meet the Earth's magnetosphere, the interaction between the two magnetic fields causes the solar storm to be repelled. However, the Earth's magnetosphere has two weak spots, at the north and south poles.
Here, the magnetic field lines are vertical.
Solar storms are able to infiltrate into the Earth's atmosphere. As these charged particles enter, they collide with the Earth's oxygen and nitrogen atoms. This interaction between high-energy atoms from the sun and the neutral atmospheric atoms excites the oxygen and nitrogen atoms. When an atom gets excited, its electrons move into an outer shell, increasing the atom's energy. However, the atoms need to calm themselves down and release energy in the form of photons,
particles of light.
This released light creates the Aurora Borealis.
Wow!
The aurora appears in different colours. This is due to the different gases in the Earth's atmosphere, since each gas emits a different wavelength of light when it is excited. Oxygen emits green light and red light at higher altitudes. Nitrogen emits blue light. Since oxygen and nitrogen make up 99% of the Earth's atmosphere, it is the mixing of these colours which produces the stunning pinks, purples and whites of auroras. The aurora typically appears in waves of light, following distinct lines across the sky. These lines are in fact the lines of force of the magnetosphere. There is also a version of the Aurora Borealis in the southern hemisphere, and is known as the Aurora Australis. The phenomenon has been spotted on Jupiter, Saturn and Uranus too.
Well, I never knew that.